Recording will stop now. Now it is. Just remind me, I paused it earlier before we officially started because I didn't really catch me just watching, waiting for people to log in. So I'm sorry about it.
Does it matter how we write the answer? Like in the book, it condenses everything. So for that problem you're working on, it would just be a squared for ab for b squared, like rather than having pluses in between each.
Whoa. If there's no plus in between, then it means times. It's totally different. Where in the book does it do that? It must be a formatting issue. You know where it does that in the book?
Hold on one sec.
Sure. But does everybody understand?
I have a
If I
question.
rewrote this without the pluses in there, it would be a totally different thing.
I have a question.
Yes.
We have now a plus 2b squared, okay? We
Yes.
have to do the parentheses again, like a plus 2b and another parentheses, a plus 2b.
What's another way to do it?
A squared and 2b squared, or 2ab squared. Can I do that?
I don't know what
Wait,
you
how-
just said. Are you saying what I'm saying, which is
Okay.
anytime I have something squared, you'll get the first guy squared, the last guy squared, and the middle guy is going to be twice these two. Whatever.
No.
So again, if you
Whatever.
know that,
Because when you say do this section, I do it, and I do like that as a squared plus 2ab
plus b squared
squared. Yes.
for the last thing squared.
Yes. Yes.
That's now listen.
Okay.
That's fine, but it's completely unnecessary. So again, I wanted to show you, we just did it the same way we did every other problem before section 6.4, right? So why pretend like there's a new thing to learn? It's the same problem. The book, I don't like this. This is a lot of math teachers do this, a lot of books do this, and they teach it this way. And I hate that shit because there's nothing different about this problem from what we were doing before. There are some interesting, oh, look, that squared is there and that squared is there and that's interesting, but it's not a necessary way to do the problem. If you do it that way, you're fine, because I know some teachers teach it that way. The book shows it that way. If you do it that way, it's fine. I just want you to realize there's no need for that. You do it the same way we do it always. Yeah.
When I do this one, I got a squared plus 4ab
And that's it?
squared. 4ab squared. No, it's wrong.
So that's not good. Yeah.
Okay.
So don't do it that way then.
Okay, that's why I asked you to understand.
Okay. Because if you don't get this answer, you're wrong.
Okay.
Now, believe it or not all mathematics is like that. That's one reason people say, I hate math because it's so black and white. You can't have, no, that's the basic shit, right? When you get to a level of math where it's fuzzy math and chaos and there's no really right answer and probability and, so we're not there. Sorry. I have no idea why I went off on that rant. Okay. Anything else? Let me see. I think I'm on my stuff, right? Let's see. That's right. You can do it, Jeff. So what about this here? All right. Oh, if you don't hate me yet, let's see what you feel about me in a minute. All right. This is interesting. Let me help you out a little bit. Now, the first step is the same idea as what we just did a minute ago. What would the first step of this problem be?
Write it 3 times.
Write it 3 times, right? And you can't, I know part of your brain is like, oh, come on, just cube that and be done with, but then you're wrong. Very fast way to get to the wrong answer. So you're just flying through everything and getting zeros. So yeah, you got to remind your brain, this is based on multiplication and that ain't multiplication, so too damn bad for us, We have to do it this way. Oh my God, Jeff. Now, I want to help you out with this because some people try to do all of these multiplications all at once, and that is remarkably insane. If I ask you, what is 4 times 5 times 7? None of you, in fact, no human can do all of those at the same time. You can't just go 4 times 5 times 7, boom, and get the, no. How do you do this? If I say don't use a calculator, how would you do this?
4 times 5.
And get the answer, right?
20.
What is 4 times
20.
5?
20 times
20.
7.
And then multiply by 7, right?
Yes.
That is the way that every person in the universe or any thinking organism that uses math like this has to do it, right? So then the
Right.
answer would be 140. So what am I saying then is do these first.
Yeah.
And this guy just comes for the ride for a minute, right? So figure out what this times this is. Try to do it. Try to see how far you get. I am pushing it a bit. I'm sorry I'm making some of your brains hurt. But that's how you know it's growing, right? Plus you pour a little bit of this on top and, you know, it all feels fine.
Got it.
That's a little math juice is what that is. Math makes so much more sense.
X squared
Oh.
minus 2.
Yeah, so when you do these, you'll get x squared. Let me see if I can do a little shortcut with you guys, right? Minus 2x minus 2x.
We have to put the parentheses again
No,
because you put the parentheses.
I don't, what do you mean? Sorry.
When
mean
you
the
begin.
here?
Yes. We have to put it
Definitely, definitely. Why?
Okay.
Because there's another piece to this, right?
again. Okay, I
Yeah.
got it.
And then negative 2 times negative 2 is plus 4. So I am multiplying this guy by this whole thing. So they each have to still be in parentheses. I like it, right? Good point. So what I just did is I just did that problem, which is actually a relatively easy example of the problems we've been doing. I just have this extra dude at the outside and he's like, is it my turn yet? And we're like, sure. So now just multiply these. And how do I do that shit? Well, x squared gets a turn, and then negative 4x gets a turn, and then 4 gets a turn. Do you guys see that? That's the important thing to realize is when do things actually become new? It's not new
Excuse
yet. Yes, what's up?
How I got just 1 4. 4. How you got, because I do the x
All right, let me well, hold on.
times
All right,
x,
all right,
that
all right,
be
all right.
x,
Let me
and x times 2.
let me not skip
Thank
steps, okay? So you get x squared.
Okay.
So that was this one, right? X times negative
Yes,
2.
I do. Yes, I do like that.
And then the negative 2.
Yes.
And then
Yes.
negative 2 times negative 2.
Yes, it's 4.
And what is negative 2x minus 2x?
Okay, you do about, okay. Okay, I got it.
Okay, so of course you have to put your like terms together as you go.
Yeah, now I understand. Thank you.
And then you do this one, he gets a turn. That is the point of multiplying polynomials is each piece of the first polynomial gets a turn to distribute.
Mm-hmm.
And then once you get all that shit, you put all your like terms together.
Okay.
So it doesn't matter how long or short either one of them is. He gets a turn. X squared times x. What's x squared times x?
3x.
No.
X cubed.
Yes. What's x squared times negative 2?
X.
Square.
Oh. Okay. X.
That's the funny thing about multiplying things that have nothing in common. You just slap them together, right? And let's see where I'm at. So he's done. Now it's this guy's turn. What's negative 4x times x?
4x squared.
Yes.
So
And then what's negative 4x times negative 2?
8x.
2.
Do you see that? Everybody
Yes.
with negative 4x times negative 2 is positive 8x. He's done. Now it's this guy's turn. What's 4 times x?
4.
And then what's 4 times negative 2? That's right, kids. Let me stop for a minute. So you've got to identify when your brain thinks something is hard, just because there's a few more steps thrown in, right? This is a longer problem because there's one more piece to it than the other ones were. Who cares? This times each of those, this times each of those. Oh, shit. All right, this times each of those. I had to write one more pair of things because that one extra dude there. So it's not harder. It's just a little more to write because there's a little more stuff in that one guy. That's all. And now, what's my like terms? The nice thing is, I want you to notice something. You don't have to realize what I'm about to say. Do you see how the bigger dude is first and the smaller dude is second? Do you see that?
Yes.
And do you see how all your like terms are lined up next to each other already? Isn't that nice? That's always going to work if you have a binomial times a trinomial. Anyway, you don't have to know all that. It's just a nice little thing that happened. So I got x cubed is all by himself, and then these two, right? And then these two, and then this guy all by himself.
Yes. The last number, what is it? Is minus 8?
Oh, is that off the screen?
Yes, sir. I got it.
All right. You gotta enjoy yourself somewhere with all this weird shit. Okay. What I desperately, the more you realize that there's nothing different with this problem, there's just a few more terms to worry about, the better off you are, right? Very first part of the problem was rewriting it. So if there was a fifth power here, that would suck, but at least you know how to rewrite it. If there was a fifth power, you would write it 5 times. Then you would do 2 and 2, you know. Does that make sense? A little bit? So, okay, you're not going to see a lot of those, if any, so don't freak out too much. All right, I'm going to erase all this.
Okay.
Okay.
Oh, scheisse. Too much ink. Ah. All right, let me see. My mouse has gone away. Bum, bum, bum. So I think, yeah, we're gonna have a short day today. Why not? Right? We deserve that. Bless you.
Thank you, sir.
I think so. Okay. So let me ask you. The funny thing is, let me get your take on this problem. Yeah. Okay. What do you guys? Let's start off nice. Sort of a review, really. Is that less clear? This is one of the properties of exponents, right? What would the answer be?
A squared.
What do you do when it's a9 times a to the 4th? What would the answer be?
Add exponents.
Yes, add exponent. So it'd be a to the
5.
13.
You're thinking about this one. So when I multiply like bases, right? The base of each of these is A. I add the powers. What physical, everyday, real world thing does that relate to? If I got a string of 9 and I string 4 more, then of course I got a string of 13, right? I always see this as a string. A9 means A times A times A times A. See that? That's a string. Have you guys ever made popcorn strings for the Christmas tree or something? No? You're all like, what the hell is this guy talking about? No, I'm sorry. Have you ever heard of other people making popcorn string things for Christmas trees? Yes, some of you guys. So you can imagine. So each popcorn is an A. There's A1 and then A squared and then A cubed, right? So I got a string of 9 and then I string 4 more on. So of course I've got 13, right? So when I multiply, I add. What do I do when I divide then? I must subtract, right? Because again, if I have 9 A's up top and 4 A's on the bottom, don't 4 of them cancel? And then how many do you have left? Well, 9 minus 4, right? So the shortcut is just subtract
Right.
the powers.
So how to say it? A5
A to the
squared.
fifth. No, A to the 5th. The only one that you say square is if there's a 2.
Oh, so
Square and cube are quick ways to say second power, third power, right? The rest of them you just say A to the 4th power, or A to the 4th, A to the 5th power, or A to the 5th. There's no shortcut words. I like it.
Thank you.
You're welcome. Okay. What about this one? And just to stop anybody before you say this, it's not x to the 5th. Sure as all hell ain't that.
-5.
Yeah. So one way to answer this is x to the -5th, right? Because 2 minus 7 is -5,
Yes.
right? Do you remember negative powers mean flip and all that kind of business? Remember that? Okay. So a slightly better way, because in general, most of the stuff we use, we don't want to use negative powers. We want to write stuff without negative powers. Now watch this, watch. How many x's would cancel between the two? How many x's would cancel? So imagine in your head, 2 x's and 7 x's. How many would you cross through? 2. So how many would be left? 5. Where?
Bottom, on the
At
bottom.
bottom, yeah. If you remember, these are the same thing, aren't they? X to the -5th means 1 over x to the 5th, because negative power means flip, right? Maybe. So that's actually old news, believe it or not. We already talked about those things. So here's the sort of new thing. So what if I had this here?
Mamma mia.
So the thing with this problem is there's 2 problems in one. That problem would be easy. And that problem would be easy, hopefully. So let's look at it this way. How many M's would be left after you kill as many as you can? 2. Where?
On the
On the
bottom.
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 How many X's would be left? And where? 7. Where?
7.
Uh,
Top.
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 Done. Right? And again, the long ass way to do this, which I don't want anyone to do, is you would write M 8 times, and then M, oh my God, right? I've lost count. Shit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then, oh God. And then you can do bam, 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 bam. And do you see how there's 2 M's? Do you see that? 2 M's on the bottom. I don't need all that shit. Because obviously it's subtraction, right? Obviously this has, because I am losing M's as they kill each other. So the shortcut is 10 minus 8 is 2, and they would be left on the bottom because that's where there are more of them, right? This is an army that exactly kills each other out. Each army person killed. This one had 8 people, this one had 10, so that one won with 2 people left over at the end. Those 2 were just sort of sitting off to the side watching, like, thank God we don't have to do this. Everybody's dying. Woo! So that is 6.5 is this stuff, right? And that's exactly how you do it. That's really all there is to it. So you can see there's 2 more M's in the bottom. Bam. You can see there's 7 more X's up top. Bam. Done. Next. And why does it work that way? Because of this. That's what's really going on in the background, but we're better than that. We don't have to write all that shit out. That's a normal cough. It's not a COVID cough. Anybody went to the grocery store and you had a cough like a normal cough and you're like, oh shit, I better not cough. People are going to throw me out of here.
They're going to start tackling you.
No, not tackling me. They're going to want to get the hell away from me, which actually might be a good tactic just to have a road to myself. Oh, there's less toilet paper. Cough. Yeah. All right. Sorry, I'll stop. All right. Any questions on that? We're actually technically a little ahead. I want to, let's see, next week, we have next week to finish up chapter 6. So I'm going to propose something to you, and you can say no to this. I was going to give us tomorrow off. No? Is that all right? Anybody not like that idea? I could use a day with one less Zoom meeting. I've been averaging about 4 Zoom meetings a day.
I need to catch up on homework.
Yeah, catch up on homework. This is a good thing. If somebody emails me and asks for it, I could have some like office hour Zoom thing tomorrow, and I would send it out to everybody. Let me ask you guys right now, would anybody want to meet at 12 tomorrow or something, or let's say 12:30 on Zoom to do anything? Anybody need that? I am good. Okay. So here's my plan then. I want, so we're going to have tomorrow off, and then we'll have Monday. You need to catch up on homework so you have more questions to ask on Monday. Oh, test corrections. Did I not put a test correction thing up here? Oh, I did. If you go into Canvas, there is a test 2 corrections place. Is that what you're talking about, Alani? Okay. And if I think everybody heard this, but if you go to Canvas, there's now a section 616263 up to 67 assignment location. If you've already turned in some homework for chapter 6, where I said chapter 6 homework, you don't have to upload it again, okay? All right. But anything new in chapter 6, just put it in the appropriate, upload it in the appropriate place on Canvas. All right. Okay. All right, guys. So If there are issues, just email me, let me know, or send me something through Canvas. I get that in my email too. Otherwise, I will see you on Monday, and we'll talk about when the next few quizzes will be on Monday. Okay?
Okay.
All
Can
right.
I ask a
Okay.
question unrelated
Yes.
to everything else, but back
Sure.
to how you write those answers without having pluses or minuses? Are you able to look at my 6.2 homework so you can just see what I've done? I don't know if I've got everything just completely backwards now or.
Hold on, let me see. Turn around. Oh, there we go. Ah, there we go. Okay, 6-2.
Yeah, like say problem 153, I guess. So that way you don't have to work out the problems, but am I writing the answers?
Oh,
wrong?
now listen. All right, Jamie. This is very important. In the original problem 153, is there any, what's the only operation in the whole thing?
Multiplication.
Done. That's why the answer only has multiplication. You can't suddenly create addition out of nowhere. The problem, like this problem, right? Is there more than just multiplication in there?
Yes.
So of course, then the answer is going to have more than just multiplication. Does that make sense?
Yes.
So those problems you're fine because the only operation is multiplication and you're multiplying. So the only thing at the end is going to be multiplication. There's just going to be one big term.
Okay, it looks like all of 6.2 was all of multiplication. So that's why I was getting concerned with my answers all kind of.
Yeah,
being
all of
condensed.
6.2 is
Okay.
really focused just on properties of exponents.
Okay, I feel
So
better.
they are dealing
now.
with one term deals, no plus and minuses in them. So that explains that. Thank you.
Got it. Thank you.
And other people are still here. I wonder if that means, I always am curious. Does that mean that some of you guys weren't ever really here? Did you log in and then go to bed? I don't know.
I'm here.
Curtis is here. Thank you. I'm not saying anything wrong about anybody. I'm just not sure. So there people go. Anybody have a question? If you don't have a question, you can just log out.
All right. You have a good day.
Take care, Curtis. Good to see you. Oh, Samir, what's up? Is it Muhammad or Samir? What do you go by? Are you there? You have a question? Or you unmute yourself? Oh, there you go.
No.
You're
Oh,
good?
sorry, sir.
Oh, okay, okay.
Goodbye.
See you.
Yes, sir.
And Yangsha, you okay? Lauren, you okay?
Yeah,
Are you
I
ready?
just want to make sure tomorrow we don't have a class.
That's right. We
Oh,
won't meet for Zoom tomorrow. Good.
Okay. See you Monday.
See you.
Thank you. Bye-bye.
Sure. Lauren, are you out there? Lauren? 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 Sorry. All right. I guess you're not really there. Okay. Well, hopefully you heard. No class tomorrow. I'm going to close the room. Bye-bye.